So, welcome everybody. This is Evidence 2 for Matter and Energy. We're going to talk a little bit about electrostatics and an experiment we did about a lemon battery. First, we need to understand what a field is. So, it is said that the field is a way of conceptualizing and mapping the force that surrounds any object and acts over another object at a distance that doesn't have a physical connection. So, knowing this, an electric field is a force field created by the attraction and the repulsion of electric charges. This is also the cause of the electric flux, and it is measured in newtons per coulomb. But what happens with the flux? Well, the flux disappears with the distance to the source that provokes the field. The electric field E is defined as the radius of the Coulomb force to the test charge. As we can see here in the formula, besides it, it's literally the same, just expressed in a different way.
Now let's continue with electric potential. Electric potential is the amount of work that we need to move a unit charge from a point reference to a specific point against the electric field. Usually this reference point is the Earth, but we can use any other one. And potential energy is measured in joules. Here we can see the formula that tells us that electric potential is obtained by multiplying the test charge times the electric field intensity times the distance between these mentioned points. And well, the potential energy increases with a positive charge that moves against an electric field and decreases when it moves with the electric field. The opposite thing happens for a negative charge unless the unit charge crosses a changing magnetic field. The potential given in any point doesn't depend on the path that it takes. Here we can see the electric field between two charge plates that are parallel. And well, as we know, opposite forces attract each other. So we can see how the positive charges from one plate are attracting the negative charges from the other one, and this is what causes electric field. Now we will learn about batteries.
So, an electric battery is a device that stores chemical energy and makes it available in an electrical form. It consists of one or two voltaic cells, which each one of them is composed by half cells that are connected in series by conductive electrolytes. So basically, the battery is composed of three basic components: the anode, the cathode, and the electrolyte. They have a separator that is often used to prevent the anode and the cathode from touching. Even though they are not actually divided into three equal parts, both anode and cathode are types of electrodes. What are electrodes? Well, electrodes are conductors in which the electricity enters and leaves accompanied in a circuit. So, what is an electrolyte? An electrolyte is a substance capable of transporting ions between the chemical reaction that happens in the anode and the cathode. The electrolyte is usually a liquid or a gel, and it inhibits the flow of the electrons so they can flow easily through the external circuit rather than through the electrolyte.
Now, how do batteries work? So these are dry cell batteries, and they are the ones we use the most nowadays. And in this case, zinc acts as the anode, a graphite core is used as the cathode, and ammonium chloride paste acts as the electrolyte. So what happens in here for it to work is that in the anode, the electrode reacts with the electrolyte and it produces electrons like more than it should. It has an excess of electrons. And since the electrolyte prevents the direct flow of electrons from anode to cathode, as we saw before, the electrons are looking for a way to be rearranged. And that is when the circuit enters. When we have a closed circuit, the electrons are going to travel through a conductive path in order to get to the cathode. And by doing this, it will provide energy to whatever is connected to the circuit. let's remember that batteries can be recharged, but eventually the reaction starts slowing down and the electrons stop flowing, and it is when we say that the battery is dead. And let's remember also that the reaction that happens between the electrolyte and the anode is called reduction oxidation, and we know it the most as redox reaction.
So now let's talk about the experiment. So as you already may know, in the lemon battery we use zinc nails that act as the anode, the negative part, and the copper acts as the cathode. Those are the positive parts. Since it attracts electrons produced by the reaction between zinc and the lemon citric acid, that acts as the electrolyte. So here, as in dry cell's battery, the citric acid and the zinc have a chemical reaction and produce electrons that need to rearrange, as said before. When connected to the lead, a circuit is formed, allowing the electrons to flow in the way they do. Now, let's remember that the function of the citric acid is also to keep the anode and the cathode separated. This is the reason why the nail and the cable remain separate in the lemon. But if they weren't, the electron would flow directly, and the lead wouldn't have had enough energy to be turned on. So the same thing would happen with the electrical potential, because if there wasn't a difference, electrons wouldn't flow at all. So the lead obviously wouldn't turn on. So now let's see how our experiment and how it went.
So in this experiment, what we did was wrapping a copper wire around a zinc nail and putting them into lemons. Here, what is happening is that the zinc nail is acting as an anode, the copper wire as a cathode, and the lemons as electrolytes of an electric battery. And well, in order to be able to see the current flowing in the circuit, we use LEDs that, as you can see, they turn on whenever the legs are in the right current. And yeah.
Finally, consider that each battery filled with a lemon generates a potential difference of between 0.5 and less than 1 volt. We assume that about 1 volt is generated in one of the lemons. So we have the electric potential of 1 volt, and we measured the distance between the nail and the wire, and it was of 3 centimeters. And with this, we were able to obtain the electric field intensity that was generated in this circuit. And well, we know that to obtain the electric potential, we have to multiply the electric field times the distance between the charges. And in order to get the electric field intensity, we had to do the opposite by dividing the electric potential into the distance. So we had 1 over 0.03, and that gave us that the electric field was of 33.33 newtons over coulomb. And thank you. That was all of our evidence.